Alright, so in this video we'll be finishing up this paper, the August 2020 Khomas Region Mathematics Higher Level Paper 1. Okay, so as you can see on the left here, we've covered most of the work, and all that's left is question 13 and 14. So we'll work through all of that in this video. Okay, so let's see what it says. In the diagram below, triangle ABC has vertices A and B and C given. In the Cartesian plane, the line BC is inclined to obtuse angle theta. Okay, they give us that on the picture nicely. Calculate the coordinates of the midpoint of AC. So midpoint of AC. Okay, so we can use the midpoint formula. In this case, we already know that the x values are the same. So all we need to do is find the halfway value between the y values. So we already know the x value is going to be 6. And for the y value, we'll just use the y value part of the midpoint formula. So 4 plus -2 divided by 2, that'll be our y value. So that gives us 4 minus 2 is 2 over 2, which is 1. So 6 and 1 will be our midpoint. And you could do the same for the x part, just say 6 plus 6 over 2 gives us 12 over 2 is 6, so we'll get 6 anyway. Calculate the area of the triangle. Okay, well, since we know this is a vertical line, that's quite nice. So what we can do is we can just draw a line straight from there all the way here, and that'll give us a nice right-angled triangle. Okay, so we can go half times base times height. So this distance here is what? From 4 to -2, so 4 minus -2 gives us 6. And from here, the difference between the x values, 6 minus -2 is 8. So area of a triangle equals half times base times height, and perpendicular height specifically. And we know this is perpendicular because this one is flat, the y values are the same here, and the x values are the same here. So it makes a right angle triangle, which means we can say half times the base times the height. Right? We can choose base 6 and height 8. And then we can just work that out. So half times 6 is 3, 3 times 8 is 24. So that's 24 squared units. If they gave us units like meters, we would have had to put that in. But without this, we could just write 24, or we could, if we wanted to, write units squared. Now we need to find the equation of line BC. It's line BC. Okay, so let's just write down those coordinates, and then we can take them to the bottom and work out from there. So B is -2, 2, and C is 6, -2. Okay, so I'm just going to drag this all the way down to where we want to use them. So we want to find the equation of the line that goes through those 2 points. So a line has equation of y equals mx plus c. To find m, which is our gradient, we say it's the change in the y values divided by the change in the x values. And in this case, that is change in y values, so let's say 2 minus -2. Divided by change in x value, so -2 minus 6. So that'll give us an m value of 2 plus 2 is 4 over -8, and that finally simplifies to -1/2. So far we have y equals -1/2 x plus c, and to find the c, a y-intercept, we can just substitute any point on the line in. So we've got 2 points that lie on the line. I'm just going to use point B and substitute that in. So our y value in point B is 2. And our x value is -2 plus c, and now we want to get c by itself. So 2 equals -1/2 times 2 is 1. Take the 1 over, so we get 1 equals c. And that gives us a final answer of y equals -1/2 x plus 1. Alright, so that's the equation of this line. What's next? Okay, calculate the sides of angle theta. So for this, let me maybe explain where this formula comes from. If we have a Cartesian plane here, x and y, and we have some line going through there, and we want to find this angle, well, we can imagine drawing a little line like that, which makes a right angle triangle. Then what is tan of this angle? Well, that's opposite divided by adjacent. So this is the change in y values divided by change in x values, right? So we know tan theta is the change in y values divided by the change in x values. But what do we know? We see here, change in y divided by change in x is just the gradient. So we know that the formula is tan of the angle is equal to the gradient. So that's what we're going to use, this little formula here. Okay, and that's for the line BC. So we need this gradient, which we found in the previous question, which is -1/2. Okay, so we can just say tan of the angle is equal to -1/2. But now, what's important here is the calculator will usually give you an acute angle, right? So in our case, we've got this line, and we're looking for this theta. Now if we do our calculator work, it'll give us the acute angle. So it'll either give us that part or this part, depending on how you look at it. So what we want to do is we want to say theta equals arctan of, and then we usually don't put the negative in. You're allowed to, but it doesn't really matter. Usually they teach us to just use the positive value, and then if we need, we use the cast diagram or something of that sort to figure out what we're looking at. And we're going to find our reference angle here. Let's go over here to Wolfram alpha and just type arctan of, and what is that? 1/2. Let's see what this gives us. Okay, so this gives us 26.57. Okay, 26.57. So that's our reference angle. So actually, we should probably not say that. We should probably say, I mean, they probably wouldn't subtract marks, but just for accuracy's sake, let's call it the reference angle. And because that's not actually angle theta, right? So 26.5%, obviously we can see that's an acute angle, so that'll either be this part or that part. And because it's a straight line, we can just say 180 minus that. 180 minus our ref angle, that'll be equal to 180 minus 26.57, and that gives us 153.43. And we said in the beginning on the instruction sheet, we're told to round off angles to one decimal place. So this will be 153.4 degrees. Okay. So the nice thing here is if you put the negative or not the negative, it doesn't really matter. Important thing is just you can check whether you're looking for an obtuse angle or an acute one. If you're looking for an acute one, that'll be the answer that you get directly from the calculator in most cases. And if you're looking for an obtuse one, you'd have to subtract the reference angle from 180 to get the actual answer we're looking for. Right, question E. The line BC is rotated through 90 degrees clockwise about its y-intercept. Write down the coordinates of the image of B after the transformation. Okay, let's get to the picture. So, I'm just going to highlight a little part of the line here. So this part here. So this whole line, but because it's rotated about this spot, about its y-intercept, we're going to rotate this thing 90 degrees clockwise, right? So that'll end up somewhere like there. Okay, so this will be B after its transformation. We need to find what are these coordinates. Okay, so that's the rotation that happened, and that's 90 degrees. Alright, so if we're rotating 90 degrees clockwise, let's just write down a little rule for that. So if we start with coordinates x, y, and we do a 90 degree clockwise rotation, then our new coordinates will be y and -x. Okay, so we started with B was -2, 2. So we rotated 90 degree clockwise. So then we see the x becomes y. So the x value here will be the y of the previous one. And the y value of this one will be negative the x value of the previous one. So the y value here will be negative of this x value. So opposite of -2, or the negative of -2 is just 2. So there we go. A nice little rule here to know for 90 degrees clockwise. Good. Finally, the last question, question 14 of this paper, some vectors. So we're told PQRS is a quadrilateral, and M is the midpoint of PQ. It's the midpoint of PS, sorry. So we know these two lengths are equal. PQ is A, it's given. QR is B, that's given. SQ is A minus 2B. Okay, so let's just make sure we read that because that's not shown exactly on the figure. Question 1. Show that PS is 2B. Okay, now an invalid answer would be just because it looks like it. Because it does look like it, but we can't just say that. Okay, so what I'm going to do is we know what SQ is, right? So I'm going to say SQ is equal to A minus 2B. But SQ is also equal to SP plus PQ, which is SP plus PQ. Alright, so let's keep the A minus 2B. SP we don't know, so we're going to write SP. PQ we know is A. Ooh, okay, so this looks promising. So now what happens if we subtract A from both sides? Right, so if we subtract A from this side, we're just left with negative 2B. Subtract A from this side, we're just left with SP. Okay, but we want PS. So PS is just negative of this one. So if we multiply both sides by negative, we get 2B equals PS. And that's what we want to show. Perfect. Now question B, write on the mathematical name for quadrilateral PQRM and give reasons. Okay, so PQRM. Okay, so we've just shown that PS is 2B, and they're equal, so each of them is just a B, right? So that's just a B, and that's a B. Okay, so we have here this figure. Since this side and this side, they're equal and parallel, then we can say that's enough reason. So that's a parallelogram. Parallelogram. And the reason is we've got a pair of opposite sides. One pair of opposite sides are, or is, I'm not actually sure, parallel and equal. Parallel and equal. Okay, so that's minimum requirements for a parallelogram. Great, and that is the end of this paper. Then we'll look at the higher level paper, paper 2, in a short little while as well.